Hello. For this tutorial, I'm going to show you how to perform basic testing in Java using JUnit 4 and InteliJ IDEA. In this tutorial, we will focus on this class and this method. This is a binary converter that simply takes a base 10 number and returns a string representation of its binary form. Now, I already went ahead and I created the test class in the source test Java folder. In Java, the convention is that each class in your system will have a corresponding test class that lives in the source test Java subfolder, and the packages are the same. So the test class will be in the same package as the class it is testing. So with this in mind, we're going to have to write our first test. In JUnit, tests are basically simply methods. So here we're going to call it public void test converter. I'm just going to name it like this. And in order to let JUnit know that this is a test, we need to annotate it with the @test annotation. So now JUnit knows the test, and already you can see IDEA also picked this up and added a few little buttons here. We're going to see what those do later. So there are two ways in which we can approach testing this class. One of them is white box testing, the other one is black box testing. I will start with black box testing, and black box testing basically ignores all the implementation, and we're just going to test it based on its specification. So we know that it will convert a number from base 10 to a string representation. So we will do that, and we're going to start with the easiest case, which in our case is the number 0. So we're going to create a new object, a new binary converter. I'm going to assign this to a variable, and we are going to do converter.convert to binary, a number 0, and again we will introduce a variable converted. Now we actually need to test and see if this value is indeed what we expect, which should be the string 0. JUnit allows you to write assertions, and assertions are basically conditions that need to be met. They live all in the assert class. We're going to use the assert equals method that basically makes sure that its two arguments are equals. So we're going to import static, and here you can just import all the possible assertions. There are a lot more assertions in here, but we will just use, this is probably the most used one, at least that's the one I use most. Assert equals takes two arguments. The first one is the expected value. In our case, it is the string 0, and the second one is the actual value, which is whatever our method returned. Then it's the value that we stored here. So now that we have our first test case, we can run it. Now there are multiple ways of running it. You can right click here and you can run this, or you can click on these guys. You can run all the tests in this class, or you can just run an individual test. However, there is no actual convenient way. If you have multiple test cases here, there's actually no convenient way of running all of them. And you can run it all in a package, and you can also, so this works. So, and you can run it. Okay, so now that we have written our first test, we need to decide, we need to run it, and you can run it here. You can see that IDEA already annotated our code, so this will just run this particular test. This here will run all the tests in our class, which we only have one. Of course, you can also go in the project view, and you can run the test here by right clicking on it, or you could run all the tests by right clicking on the Java, and you can run all tests, and this will automatically run all tests. And as you can see, it does do all the tests in testing. Now that we have written our first test, we want to see how effective this test is and how well it actually tests our method. So to do that, we can run this test with coverage. So to run it with coverage, instead of clicking the normal run button, you run the run button, which has this little checkered pattern underneath, or waffle iron. So if you run that, it runs all of them, and it runs them with coverage, and it's gonna give us a report that basically says, this is the coverage. And right now we are at 72% for our particular package. And if we go in the file, I'm going to close this, you can see that it actually annotates, and green are lines of code that are executed, and red are lines of code that are not executed. So we execute all these, but we do not go in the while loop, and we do not go in the if statement. And this is where white box testings come into play. In white box testing, we will write cases based on the implementation. So in this case, we see that there is a special condition if the result is negative. So let's write a test based on this. We're going to call it public void test negative, and we're going to do exactly the same as we do here, but we're going to convert -1, and we should expect -1. And again, we can rerun our tests, and we can see that coverage now has improved. It is at 81%. And if we go back to the class, you can see that now that particular line is covered. And then we can do this until we achieve 100% coverage. You can see that in our test case, we have code duplication, right? We basically, for each test, we create this new object. In JUnit, you can actually extract common bits into a method that is executed before every test. And that method is annotated with the before annotation, public void before, and this will be called before each and every test. So what we can do is we can cut this, and of course, in order for this object to be visible to all these tests, we have to convert it into a field. To do that, we can use the refactoring engine. We can right-click and click refactor, and we will have extract field and initializing current method. Sure. We're going to do it with the default, right? So this automatically converted to a field, and as you can see, this method already picked it up. We're going to delete this initialization here, and now this will basically create before each test, each execution of these, this will run, and it will basically create us a new object. Of course, we can also inline this variable, but I think it's going to make it more clear. So in order to make sure that we didn't really screw anything up, we can run all the tests again. I'm not going to run with coverage because coverage didn't change, and again, they all run. A very important condition when you write tests is that each of these test cases needs to be independent. And that is for two reasons. First of all, JUnit does not really guarantee an order in which these tests are executed. The order is not deterministic because it depends on the internal workings of JUnit itself. And second of all, if you have tests that depend each other, when a test fails, it would be very difficult to understand why did it fail. Right? I mean, if this test case here were to depend on this test case here, then you don't know, well, is the failure simply because this test case failed or simply because this guy did not set up something right. So by having independent tests, you get a very good picture. If a test fails, you know exactly why it failed. We're still at 82% coverage. We still want to test these, and basically we see that this guy is this loop is while it is greater than 1. So we should convert something that is greater than 1. So let's do that. 5. We're going to convert to the number 5, and convert to binary 5, and converted. And we're going to again assert that our return from the method actually expects. So 5 in binary should be 0, 1, 0. Converted. I have a typo. And again, we can run all the tests. And you can see it actually passed. So I'm gonna show you what happens when a test doesn't pass. I'm gonna add another 0 here, and I'm gonna run again. So what happens when a test fails? You can see it goes to this kind of warning, and you can click on it, and it basically tells you it is a comparison failure because it expected 10, 10, and it got 101 or 101. And you can also click, and it will take you to the exact assertion that failed. So again, this is very helpful to kind of debug and understand why does it fail. And also it annotates here that this test has failed. So we're going to save this, go back to original assertion, and this will work fine. Okay, so we're going to run this with coverage, and we should have 100% line coverage. Yes, exactly. Right. So basically now everything's green, which means we completely covered this method. Now, having 100% line coverage doesn't necessarily mean we weeded out all the bugs, because we still don't test all possible flow paths and possible branch combinations. Right? I mean, there's still a possibility there might be a bug if number's negative and base 10. Also, another good strategy for testing is to test boundary conditions. Right? So what happens if I really give this guy a really big number? In Java, the integer class has a max value property that we can use. So let's write a test for this boundary condition. Test very large. Okay. And we are going to convert to binary integer dot max value. This is the maximum value. All integers in Java are 32 bits, so the maximum value is 2 to the 32nd power minus 1. So we're going to use that, and we're going to do that, converted. So the value here should be 32 ones. So we expect this value, put a semicolon at the end, and this will basically be our test case. So again, we're going to run it, and it should also be fine. Another good test case that we can perform is what happens if we give it invalid values. Now, because Java is a strongly typed language, we cannot actually give it anything other than an integer because it will not compile. So the compiler kind of saves us that effort. And of course, and there's also another type of test case, which I'll not go here. Those are known as regression tests. And regression tests happen after you find bugs. A regression test is basically a test that tests the presence of a particular bug. So if that test fails, you know that you have a bug. And you generally write them when you debug the code. It's always a good idea to write a test that exposes the bugs, that basically fails, and then when you fix the bug, that test should pass. In the end, you get a test suite, a regression test suite that has all of these kind of bug fixing tests. And you will run these after each change, and they basically protect you against a regression. If one of these tests fail, then you know you introduced a bug that at some point was removed. And of course, in a large project, these test cases and these test suites will grow. However, they do give you a very nice safety net that you can make changes, you can go ahead and refactor your code and still be reasonably sure that you will not reintroduce bugs or maybe introduce new ones. This concludes the short tutorial on testing, and I hope you find it useful.